Now we go through what example 3. Let's go through it and let's see how it goes. This is saying Milcon was conducting a research on the amount of cough syrup consumed by people that had flu. Okay, so whatever, it was a research, blah, blah, blah. It did this by measuring the volume to the nearest millimeter. So when I'm reading, let me just give you a tip. You don't have to understand what the problem is talking about. Why you read is you'll be skimming to find if there is any important information. So here I'm reading, and I've been told that something was measured to the nearest. When I see this to the nearest, I have to watch out. So the moment I see a statement to the nearest, I should underline that's a key statement there. That's a key statement there. Okay. Now that the clients at a local, whatever. So it did this by measuring the volume to the nearest millimeter that the clients at a local pharmacy brought back in the 200 millimeter bottle they had purchased when sick. So now the thing is, I just read the question because we have to read the question, but I didn't have to read the question. Okay, we don't need to read the question to be able to answer, because if we go to, the sentence, these wording, we need to just go to the questions and see what the questions want, and we can go back here and look if there is anything important that could help us to answer the questions that they've asked. Here it's saying state the class boundaries of each interval and calculate frequency densities. So what is the first one? Class boundaries, number 1, and of each interval, and then calculate 2 frequency densities. So the first thing to know here is that class boundary and interval is the same thing. So when they say state the class boundaries of each interval, okay, the boundaries are the ends of the interval. So when we say boundaries, we are saying interval ends. Okay, so when we say interval width is the same as the width from one boundary to another. So boundaries make an interval. So they want the class boundaries, which means the ends of the intervals, and calculate the frequency density. So first we're going to need to get the class boundaries, then calculate the frequency densities, as if we're drawing a histogram. They say it needed to draw a histogram, but they didn't say we should draw it, but they said we should find those things. So when we're making our histogram, to be able to draw it, we need to find these things, right? The class boundary as well as the class boundaries as well as the frequency densities. So what do we do when we are doing that? We make a table. Now, we already have a table right now. And what is the name of this table that we're seeing in green? This table is called a frequency distribution. Remember, we said we will see 2 types of tables: frequency distribution and probability distribution. So here we have a table. It's called a frequency distribution. Why? It gives us data, which is the volume, and it gives us the frequency. So this is called a frequency distribution table, or just a frequency distribution. Great. Now, what are we going to do with this frequency distribution? We're going to convert it into a table that shows us boundaries. We want that table. So what do? We take this row, volume, and we make it a column. So volume nearest millimeter, volume, and in brackets it says to the nearest mil. Volume to the nearest mil, because they say to the nearest 1 milliliter. Then after that, the next one is obviously now going to be boundaries. Okay, we now need to know the boundaries. The lower class boundary, say L dot C dot B, and the upper class boundary, U dot C dot B. Right, so we are going to make it. We'll box it later. Then after, what do we make? Of course, when we now know the boundaries, we can be able to get the interval width. Okay. Whew, I don't have much space. Let me say interval width, right? And then when we know the interval width, then what else do we need to know? Then we can be able to put our frequency. Then we can be able to get frequency density. So let me write it nicely to say, yes, interval width Then here, once I know it, I can put the frequency. And once I know interval width and frequency, I can be able to get frequency density. Great. Now let's go ahead and let's put our stuff. Going to make it go up to here. Okay. Then we'll have another one which goes up to down there as well. Here is another one. Okay, and then we keep going. I'll try to be as fast as I can. So frequency density like that. We go down like that. It gets up to here. And then what am I going to do? So I'm getting up to here. I close it like this. Then I'm going to really make my table nice like that. Don't forget that. Okay. Then we go ahead. We close the top as well. Great. Now let's start to put in. So we go to volume. Here it was written volume, 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 volume. But now we're going to put it going down, right? Yeah. So what is the first one? 0 to 9. So I'm going to put 0 to 9. And then the second one is here, 10 to 39. I'll put it going down now. Remember that. 10 to 39. What's the next one? 40 to 89. I'll put it 40 to 89. Then the next one, 90 to 200. So I'll now say 90 all the way to 200. Sure. Now, what are we going to do now? Well, what we're going to do is we now need to start putting our boundaries. Now, did we get it in boundary notation? No. In interval notation, no, it's not in interval notation. These things 0 and 9 are definitely not the intervals. If they were intervals, we would have inequality 0 less than or equal to volume. Maybe they'll put a V, which is less than 9, something like that. And then they would continue from 9 going on. But this is not interval notation. This is the one where we have dashes. So we can't put 0 and 9 as our boundaries. They are not. They are not the boundaries. So we need to put the boundaries. Okay, now, this is how you do it. For boundaries, remember that we always go to what it says to the nearest. Look here. It says to the nearest what? Millimeter. So I'm going to say 1 milliliter, divided by 2, because they say to the nearest milliliter, which is 1. So I'll say 1 milliliter divided by 2, I'll get 0.5 mils. So that means I'm going to be adding 0.5 to the upper bound and reducing it from the lower bound to get my boundaries. Okay, from the end, these ends, 0 and 9. So now what I'm going to do is 0 is the smaller one, right? Yes, so you say remove 0.5 from 0. Now, and put it as negative 0.5. Because if you say 0 minus 0.5, you get negative 0.5. Which is true, you could do that. But we don't do it for things that are continuous. The lower bound, listen here, and be careful. The lower bound, that is if it starts at 0, for your data that starts at 0. If it is continuous, then we do not subtract from it. Okay? Only this guy, but the others we're going to be doing the same. So that means here is volume, because we are dealing with volume. Is volume continuous or discrete? We all know it is continuous. You say to me, how do you know that it is continuous? Well, point number 1 is it's measured. It's not counted. Okay? If it's things that are counted, we know that they are discrete. Okay? Number of people, number of dogs, whatever those are the things that we are dealing with. But this is something that we have that is measured, so it's going to be continuous. Because volume doesn't take whole numbers like 1, 2, 3, 4, 5. Okay? It has any value within a range. That can be the volume. So that means here, since it's continuous, I'm just going to put my lower bound as 0, lower class bound as 0. Then the upper bound, I have to add 0.5 because that's the answer we got here. So it'll be 9.5. Okay, to be 9.5. Then from 10, I reduce 0.5. You say 10 minus 0.5, you get 9.5. 39, you add 0.5 because it's the upper bound. You get 39.5. So now we are now doing it to everyone, but we just didn't do it for 0. Why? We don't do it when it's continuous. We'll still need to change because there's a dash, not inequality signs. But for the 0, we don't change here for continuous things. So here we have 40, we reduce 0.5, we'll get 39.5. 89, we add 0.5, you get 89.5. 90, you remove 0.5, you get 89.5. 200, you add, you get 200.5. 200.5. These are your boundaries. Now we can be able to get the interval width. So we start. 9.5 minus 0, you get interval width of 9.5. Okay? We keep going. Interval width for this one, 39.5. 39.5 minus 9.5. That's the next one. So I'll say 39.5 minus 9.5. We'll get 30, of course, definitely. Then here, 89.5 minus 39.5. This looks like a 50. Yes, it is 50. Then here we go 200.5 minus 89.5. What do we get? 111. So we get 111. Wow. Now we go to frequency. Let's start. Frequency. Do we have to look for it? No, it's been given. We go back to our table. Remember, it's given horizontally like that. But we are now going to put it going down. So it's going to be 20, 18, 12, and 40. So first one is 20. Second one is 18. Third one is 12. Then the fourth one is 40. We are done. Then now we can be able to calculate our frequency density. Remember that frequency density is going to be frequency over width. Okay, how much over the space? Then you know the density. So it will be frequency 20 over the width 9.5. Then the second one will be frequency 18 over the width 30. The third one will be 12 over 50. Then the other one 40 over 111. What do we get as our frequency densities? Okay, we can go ahead and find 20 divided by 9.5. We'll get 2.105. So we could put it. Frequency density now is going to be 2.105. So I can say 2.11. Then here, 18 over 30. So I'd say 18 divided by 30. We'll get 0.6. So this is 0.6. Then here, 12 divided by 50. We'll get 0.24. Then 40 divided by 111 would get 0.36. Okay, now these are going to be your frequency densities, and we can be able to plot them on our histogram. Great, we can be able to put them and make a histogram. Now let's look at the question. State the model class. That is question number 2 now. This was solution 1. Okay, for our solutions, this was part 1. Now we go to part 2. State the model class. Model class is the class with the highest frequency density. Okay, if you're looking at it on a diagram, it has the highest height. It is the highest. It is the biggest height. So it is the highest. And in here, we can see that the thing with the highest frequency density, we want it as a class. Here you'll be asked for model class. So we are looking here at the volume. So what is it? 0 to 9 has the highest, right? And that is how we write it. We say it is 0 to 9, the original version, right? With this dash. And we have it, and we are done. This gives us all the things that we need. Goodbye for now. We'll see you in the next video.